Great to see you here again at the Math Survival Guide. My name is Luc de Ceuster, founder of the Ceuster Academy, and in this video, a new video about polynomials, I'm going to talk about adding polynomials. But before we continue, do not forget to click the subscribe button, click the bell button, so every time we have a new video, you will be informed about it. Let's have a look at adding polynomials. When we look at polynomials, we have to see how we can add and subtract polynomials or do different operations like multiplications and so on. Here we look at adding polynomials. And we have to consider two polynomials, a index n referring to the order of the polynomial, and a second polynomial b, index m, where the order is equal to m. So basically we want to find what is the sum of those two polynomials. And in order to do that, we're going to look at two different cases. Case 1, we have that both polynomials have the same order. So basically we have the first polynomial an times x to the power n plus and so on, a1 x to the power 1 plus a0, and we add the second polynomial to this polynomial. So the second polynomial is b index n multiplied with x to the power n and so on until we reach b0. Now we see that the two coefficients, the two variables x in these two polynomials have the same highest order. So x to the n and x to the n. Now, when we look at this, we have to start doing some operations. And the first thing what we're going to do is to group the terms. So basically, we group the terms with the same power. Now, first of all, we start with x to the power n. So we have a index n times x to the power n plus b index n times x to the power n. And we do that for all the other parameters, for all the other powers of x. So the next one we have a1x plus b1x, and the last one is a0 plus b0. And now we can apply the rules of addition, and we can isolate, we can take out x to the power I out of the brackets. So for the first one, we find that the sum is an plus bn multiplied with x to the power n. And we do that for all the powers of x. So we have a1 plus b1 times x plus a0 plus b0. This is quite easy because we have two polynomials of the same order and the addition is very easy to obtain. We can also write this in a different way, because we can use the summation notation of the two polynomials, and it will give us the expression that an plus b and the sum of those two polynomials is equal to the sum starting from I equal to 0 to n, a index I multiplied with x to the power I, plus the summation of j starting from 0 to n from b j index j multiply with x to the power j, and the fact that I and j are in fact identical, I can rewrite this as the sum of those two polynomials is the sum going from I equal to 0 to n of ai plus bi multiplied by x to the power I. So basically we're adding the two coefficients of the respective powers of x, and that's basically the simplified notation of the sum of those two polynomials. Let's have an exercise. Let's consider two polynomials. an is 5x to the power 3 plus 2x minus 1, and the second polynomial is bn equal to 6 to the times x to the power 3 plus 2 times x to the square minus 3. We see that both polynomials have the same order, which means that we have in fact all here to do the addition like we did before. So first of all, we have the sum of those two. So we have 5x to the power 3 plus 2x minus 1 plus the second polynomial 6x to the power 3 plus 2x to the square minus 3. And we start by grouping the terms. So we first have 5x to the power 3 plus 6x to the power 3. Then we have 2x to the power square. Then we have 2x. And then we have minus 1 and minus 3. And when we add the terms, the coefficients of the powers of x which are identical, I can say that we have 5 plus 6x to the power 3 plus 2x to the square plus 2x minus or plus minus 1 minus 3, which gives us the final result. It is 11x to the power 3 plus 2x to the square plus 2x minus 4. Now let's have a look at a different way how to deal with this. And this is a way that I've been using because it simplifies and it becomes easier to find all the terms with the same power, x to the same power. And it's certainly interesting when you have more polynomials to add. So basically I write the first polynomial and I add there the term which is missing. So first polynomial we have no term in x to the square. It means that a index 2 for that parameter is equal to 0. So we replace it by 0x to the square and then we have plus 2x minus 1. The same we do for the second polynomial. We have 6x to the power 3 plus 2x to the square. Here we don't have a term in x, so we replace it by 0 times x minus 3. It just means that the coefficient of x in that case is equal to 0. Now we look at the different parameters. First we look at 5x to the third plus 6x to the third. We add those two terms. And basically it means that we add 5 and 6 and we find 11x to the third. So we write 11x to the third and we do the same for the second terms, right? The terms here to the square. We find 0x to the square plus 2x to the square, which gives us 2x to the square, and we add it again to the equation. Now we do it for the third term. So here we have 2x plus 0x gives us 2x. So that's the next term. And the last term is minus 1 minus 3, which is equal to minus 4, which I add here. And I find the same result as before. This is a little bit easier because it allows us to identify the terms with the same power, with the same order, so that we don't miss out any terms, and it's an easier way to do the exercise. I like to simplify things in life and try to find ways that will make our life easier and reduce the problems, the risk of errors. So we find again an plus bn. Now what happens when the two orders, the two polynomials, have a different order? So in this case, the powers n and m are not the same anymore. What we find here is first polynomial an summation from I equal to 0 to n of a index I times x to the power of I. And we can write the same for the second polynomial. Now we have bm, and m and n are different. Let's assume that n is larger than m. It means that the order of the polynomial a is higher than the order of the polynomial b. We can write the sum of those two polynomials as follows. First we have all the terms an times x to the power n up to a n plus 1 x to the power n plus 1. These are the terms of polynomial a with the order, with the power higher than those of polynomial b. Now we find the additional elements, and now we have elements, we have powers of x, which appear in both polynomials. So now we can say that am plus bm times x to the power m, because before we add b's, the value of the b coefficients were equal to 0, but now they are different from 0, and we find all those coefficients. So we find a2 plus b2 times x to the square plus a1 plus b1 times x plus a0 plus b0. So basically we have two parts that we can do. We can first take the terms of a which have a power higher than the order of polynomial b, and then we add the two remaining parts of the polynomials of a, we add it to the polynomial b. Now this is the same equation that we had, so we have the same parameters that we have before, and afterwards we have the coefficients that are not equal to 0 for a and b. Now what we can do here is we can write this again as a sum, and the first part what we have are the terms that are in fact in common with a and b. So these are the terms which have the same order in a and b, and we can write this as the summation of index I going from 0 to m of the coefficient a index I plus b index I times x to the power I, and the remaining part, the first part, these are the coefficients or the terms of the polynomial which have a power higher than m, and we can write this also as a summation, and that summation is I, index I starting from m plus 1 up to n for ai times x to the power I, and those are the two parts of this new polynomial. Let's get an example here. It will be a lot easier to look at this taking a simple example. We take polynomial a, 5x to the power 6 plus 3x to the power 5 plus 2x to the power 4 plus 3x to the square plus 4x plus 2. The second polynomial b is 4x to the power 4 plus 2x to the power 3 plus 4x to the square plus 3x plus 5. We see that the order of polynomial a is equal to 6 and b has an order equal to 4. And when we calculate the addition, we start with the parameters, the terms of polynomial a with the order, with the power higher than the order of b. So these are the first parameters that I can write down. So I find 5x to the power 6 plus 3x to the power 5. And now we add the powers, the remaining powers in blue, which are in fact the powers or the order 4 terms of a and b. The next thing to do is to add those terms. So we find 5x to the power 6 plus 3x to the power 5. We identify the next power, so x to the 4, we have two terms, 2x to the power 4 and 4x to the power 4, which gives us 6x to the power 4. We do the same for the third power, so there is only one term with a coefficient different from 0 with x to the power 3, so we have 2x to the power 3. Then we look at the terms to the square, and we have 3x to the square plus 4x to the square, which gives us 7x to the square. And now we look at the two terms in x. We have 4x plus 3x, which gives us 7x. And the last terms are 2 and 5. So we add 2 plus 5, which is in fact equal to 7. So basically this is the example of a sum of two polynomials where the order of the two polynomials is different. Let's have a look again at those two polynomials and see what we can do here. So basically we have an, and again we are going to write one polynomial below the other ones and aligning the terms. So we have 5x to the 6 plus 3x to the power 5 plus 2x to the power 4 plus 0x to the power 3 plus 3x squared plus 4x plus 2. And we write the first term of b under the term of a with x to the power 4. So we have 4x to the power 4 plus 2x to the power 3 plus 4x to the power 2 plus 3x plus 5. And we calculate the first terms. That's easy because we don't have any other terms to add. So we find here 5 to the times x to the power 6 plus 3x to the power 5. We combine the two terms in x to the power 4. So we have 2x to the power 4 plus 4x to the power 4, which gives us 2 plus 4 times x to the power 4, which is basically 6 to the square. And we put it as the next term in the equation. Now the following term, we have 0x to the third plus 2x to the third, which gives us 0 plus 2 times x to the third, basically just 2 times x to the power 3, and we add it also to the equation. The next term is 3x to the square plus 4x to the square. So basically we find here 3 plus 4 times x to the square, which is 7x to the square. And we add it to the equation. So we have 7x to the square here. Now we have 4x and 3x, so we have 4x plus 3x, and we add the two coefficients 4 plus 3x, which gives us again 7x. And now we go for the last term, 2 plus 5, which gives us again a coefficient equal to 7. And finally, this is the result of this equation. And we can say that the result, we can rewrite the result being an plus bm is 5x to the power 6 plus 3x to the power 5 plus 6x to the power 4 plus 2x to the power 3 plus 7x to the square plus 7x plus 7. Let's have some conclusions at the end of this video session. We're almost at the end. It was a little bit longer this session, but it's very important to draw some conclusions. Now, when we look at an and bm, the two polynomials that we added, n and m being the order of those respective polynomials. When we have n equal to m, then we see that the order of an plus bm is equal to n. Both have the same order, so the order of the addition of those two polynomials is equal to n. When n is larger than m, then we find that the order of the addition of the two polynomials is equal to the order of the highest polynomial, and basically that's the result of this video. So finally we see when we add polynomials, when they have the same order, the order of the addition of the two polynomials is equal to the order of both polynomials. When one polynomial has a higher order and we add those two polynomials, in that case the new polynomial has an order which is equal to the order of the polynomial with the highest power of x. That was it for this video, introducing the addition of polynomials. We will do more exercises of this. Anyway, before you leave, do not forget to click the subscribe button. Click the bell button so every time we have a new video, you will be informed by YouTube. I thank you very much, and I'm looking forward to seeing you in our next videos. Thank you and bye-bye.